So today we have Professor Robert Geller with us. He has completed his HTL in civil engineering, after which he pursued PhD in mining and tunneling at Montana University, Leoben, specializing in geomechanics, tunnel construction, and structural civil engineering. Professor Galler held leading position in numerous projects. Professor Galler also served as the project manager for one of the design consortium for burner-based tunnel project. Professor Galler has been a board member of Austrian Society of Geomechanics since 2000 and has been a professor of subsurface engineering at Montana University since November 2006. In September 2013, Professor Galler was elected as the ITA CET chairperson. Since 2015, he has been the department head of ZaB, a unique underground research and development center, as well as training and education center, and also serves as department head for mineral resource engineering since July 2016. We welcome you, Dr. Geller, on our platform, and it's an honor to have you on our platform, sir. You may now start your presentation.
Dear colleagues, it's a great pleasure for me to be with you and to be able to tell you something about the underground research which we are doing, and this time focusing on a one-to-one scale underground research center, which we call ZaB, which is the meaning is a center within a mining area. And you see the mining area here on my first slide where we are. We are placed up here in the area where no mining is going on anymore. We are sitting in the, I would say, largest Middle European iron ore mine, which was producing iron ore from the underground until 1986. In 1986, they switched completely to open pit mining, what you see here on the slide, and we have a forecast to do that in that area the next 40 years. In the area where we are, where you see this white spot here, we have an iron ore content which is too little, so that mining for iron ore is not done, but it's ideal for us because there are so many underground galleries already existing when we started that it was a perfect center for us to start a one-to-one scale research in that area. Now, the sea level where we are is 1,100 meters. You see the portal areas from the railway tunnels here. I will then show you a good overview of all the center. Our intention at that time, when we started to create this underground center, was to make tests and education in the field of tunneling, in all fields of tunneling, I have to say, from the construction, starting before, of course, with the design, and then also the operation of tunnels. And as we have two major categories here, we subdivided the system in railway engineering and in motorway engineering, as they also have different cross sections. The reason why to start it was we are building about 200 kilometers of railway tunnels right now. This includes some longer tunnels, like the Semmering has 2 times 27 kilometers. The core arm has 2 times 33 kilometers, and the Brenner base tunnel has 3 times about 60 kilometers. So, and there are a lot of shorter tunnels in between. So the railway network is now really built up, and what was decided is that we are switching from double track tunnels to single track, but always build 2 tubes for safety reasons. And that was a kind of engine to produce this underground research center in that time frame. Now let's have a bird's view to give you a little bit more of overview where we are. These are here the railway tunnels. And by starting the project, we used a small gallery from the mining, which is going through all the mountain here, which has a length of 1.4 kilometers. Had the good opportunity that we don't need any ventilation, we don't need any pumps for that, because the old miners had foreseen that there is an inclination on this gallery, so that we don't have to pump something, and we have fresh air all the time, because the levels of the portals are situated on different sea levels. Having this tunnel available for smaller tunnel fires, for the training for fire brigades, etc., the wish came up to build a one-to-one scale tunnels, and we started with the railway tunnels. And by doing so, we decided to, let's say, bring all the equipment of a railway tunnel into the right-hand side tunnel, which is our so-called eastern tunnel profile. And we built this tunnel as is foreseen by the standards. So this means we have a double shell, we have an outer shotcrete shell, we have an inner cast in place concrete shell, and all the equipment which is in a railway tunnel. On the other side, the left-hand side tunnel, the so-called western tube, has no inner lining, because we had a research project from 2008 to 2016 where we figured out that there is absolutely or almost no degradation of the shotcrete linings in tunnels which are 30 to 40 years old. And what we wanted to see is if it is possible to build that tunnel with single line, so just with a temporary lining, and now watch on the degradation of the bolts, of the shotcrete, take samples on a yearly basis, so to really get an impression what is the degradation if we would do that in a single lined structure. This, of course, has a really output then, because if we would be able to, let's say, develop a little bit more on the shotcrete material and being able to build that just single lined, then this would mean less excavation. Less excavation automatically means less landfill, where we bring this excavation to. And at the same time means less construction material used, has an outcome to less wire mesh, less arches, less bolts, less shotcrete. So this has, of course, a tremendous result if we could once decide to build it single lined instead of the double lining what we do. In the double lined solution, we try to make it without any reinforcement in the inner lining to see if the cracks occur, or if not, then we have time enough now to observe what is going on over the time. Then what we have decided here is we wanted to connect the new tunnel structures with the mining galleries. That's what we did here. We decided to make a cross passage cross section. So what is normally used between two tubes, and we sorted out a distance between the tubes, which is quite normal, which is 30 meters between the tubes. So that we have a complete realistic cross passage in here, fully equipped with communication systems, with ventilation, with light, everything what has to be brought into a real scale cross passage, so that we can also train people in how to behave if something happens in the railway tunnel. I will show you photos afterwards so that we can really invite also the population to train how to escape and what do you do in case of a technical problem in a railway tunnel. The left-hand side tunnel for the railways is very much used for full-scale fire tests and is therefore not equipped with a track so that we can easily run in with our fire brigades cars and so on. Then we go further on the other two tubes. You see here two motorway tubes, full scale. Motorway tube has a larger cross section than these single track railway tubes. Also here we decided to have a certain section, about 150 meters, fully equipped with all the equipment which you find in a modern motorway tunnel, where we can also reinstall always the newest systems which are coming up or which are developed. As it's also a developing center, we prepared that in a way so that you can always exchange and bring your newer models to test ventilation systems, to test all these let's say observation systems for communication, etc. in this section. And this section is, again, as you see the two lines, a double line system where we have everything built in so that we can also train the population in the question: what happens if you have an accident? How do you behave? What are the necessary steps to be done in case you come into an accident in a motorway tunnel? We then built a second tube, again single lined, same motivation than we had here, but a little bit larger scale. And we also have a cross passage, which is this GQ1, which is again fully equipped so that we can really train with the fire brigades what happens in case of a fire. How do we really go into the tunnel? We can do that here in a driven way, because we have a cross passage down there where also fire brigade cars can go in, or in a smaller way that you can only walk through. Both cross passages are available in real scale. So we said it would be good to have the training opportunities for both situations available. In this motorway tunnel, we incorporated a so-called water mist system. So you produce a fog in case of a fire, and what we try to do is to do a fire distinguishing with the system in future. And then we set up a completely new training area so that our volunteers working at the fire brigade can be trained for full fires underground. This is driven by gas, so that we can switch off immediately the gas which is coming from outside, from a building which is situated right here, so that if something goes wrong, we can switch off the fire from 1 second to the other, and we can switch off the smoke from 1 second to the other. You see a lot of other tunnel galleries there. These are smaller ones. Here in this section, we can do blasting tests so that we try to use new blasting materials and measure what are the vibrations caused on the neighboring underground sections. And then we have quite long, about a 500 meter long section without any support in, so that we can also make bolting trainings, shotcrete trainings in that section. To give you a better overview, I thought it would be worth to make a 3D animation on that. Just try to do that. In this area, we have our offices, our lecture rooms, and then these are the railway tunnels, and these here are the motorway tunnels. The smaller lines here are the mining tunnels, which we got from the mining industry, so to say, where we are able to use them for any other purposes. The system is ready to be enlarged, and what we were asked is, could we also set up a subway station in that area? And the red drawing, what I'm showing here, is just a drawing, is just a design. A cost estimation was done for the colleagues from the subway, and the question is if we will build that, yes or no. For the moment, it's just a design, just for your info. Now to the cross sections again back. We said the one is double lined, as you can see here. You see it's a drain tunnel. We have the drainage pipes down there, the main collector here, also a dewatering system for the inner lining, and 3 research projects are running, focusing on this question of the problems of sintering in these drainage pipes. This is a very important and very interesting question. How can we avoid that these pipes here are blocked? Based on the geochemistry, this can happen. Because if these pipes are blocked, or let's say are full with sinter, then we have the problem that the water table raises. And if the water table raises, then we get some pressure from the water onto our outer lining, inner lining, and then we would see cracks in the lining, what we have to avoid. And that's why we are focusing with one project, for example, on this, how to keep the pipes clean, or how to clean it from the very beginning. This is a very special topic. I just wanted to mention one research topic, because you don't see these pipes from when we are walking in the tunnel. I just wanted to say there are research projects going on this one. We did some research on the membrane, which is in between these two linings. I mentioned already degradation of materials is an interesting topic. And as I said, one of the tubes is fully equipped with the railway system. The other tube is, so to say, empty. We did not put the wagons into this tube because we need this single track tube for intensively for fire tests. That's why we didn't put something into. I just wanted to give you an impression about the construction steps we did. Of course, we have so-called sealing membranes as used, and then the inner lining. The difference to many countries in the inner lining is that we are proposing to do that without any reinforcement, because we see if we are using the right concrete quality that it perfectly works. And you see on the right-hand side, we have this tunnel with the inner lining. On the left-hand side, we have the tunnel just with the shotcrete lining. And we'll see how the degradation is going on this and on this. When we build a tunnel like this, we of course try to bring our monitoring a step further. So before starting the tunneling works, we had set an inclinometer down there. This is also for bringing that features into the lectures for the students, and not only for the students, but also for the miners who want to be trained up on the most modern technologies which are used right now. Then, of course, we have several cross passages, and as you see, some colleagues from the fire brigade standing there. We have these tests with the fire brigades. In the eastern tube, we installed also this railway line. And then we fully equipped it. So we have already these electric, not cables anymore, but tracks. Then from AC electrics, then we have a ventilation unit in there, and we also have this handrail. The handrail is a tool which, in my opinion, raises up safety a lot, because if you have some lights anywhere here on this area where you are, let's say, outside of the 2.2 meters height, or you mount it even in the ceiling as we did it here in the crown, then this will be quite quick under smoke in case of a fire, and you will see nothing. So having developed this handrail, I think this is really a safety feature for the future. It has about 1 lux per meter, and you can tell your children, you can tell the old people, okay, never lose touching this handrail in case of any problems in the railway tunnel, and you will automatically be guided to the cross passage. And this is a feature I think this is worth to bring in all the tunnels, because I don't know if you have tried it once to be in a complete darkness situation, how fast you really lose your orientation. So I think this is a very important and very good feature. On the other side, I told you already that we have the motorway tunnels. Here we decided for 2 different types. Besides just having this double line tunnel and the single line tunnel as we see it in this picture, we also decided for having a section with a ceiling in between. You know, if you have a tunnel which is, let's say, longer than 4 kilometers or 5 kilometers in this range, depending on the traffic what you have, depending on the amount of lorries, and of course also on the inclination of your alignment, you will produce, let's say, poisonous gases in the tunnel. CO is an example. And then, of course, you have to press in fresh air from another channel. And this channel is here, the channel which is separated by this ceiling, so that you get or bring the fresh air to the drivers of the lorries or cars, and then bring out the harmed air through the main tunnel. And we wanted to have this situation also in our research center, because having this available, we can do really good studies on ventilation aspects, switching on the big ventilation unit, which blows in the fresh air or sucks out the harmed smoky air from the area here in case of a fire, for example. And in parallel, having this other gallery available with the longitudinal ventilation concept, where we have these fans situated in the ceiling. These I mean are quite standardized cross sections, and in this case, mentioned before, just watching degradation, and is it really possible to build tunnels in this thin lining structure on the long run. Life cycle, of course, is a topic. Having a view into this motorway tunnel, you see here the water mist system, with which we would like to keep the fire down in case something happens. Is a question of development. Should we place really these water mist systems in future in all our tunnels, so that we protect in case of a fire our shell? Is it possible to make fire distinguishing with the systems in future? These are the questions. Or are there some arguments which are also against it? I mean, there are some, but the question is, what are the pros and the cons of such a system? In the other section of this motorway tunnel, we built everything in what is in a modern motorway tunnel equipped. So we have these safety or the emergency cells, then we have the loudspeakers, we have all the measurement systems which are to be installed in a motorway tunnel. We also have these openings here for sucking out the smoke in case of smoke or fire. There are jalousies in which can be steered from a safety center. There are, of course, hydrants installed into in the area, and then we have this section which is built up for training the fire brigades, as mentioned before, on full fires in this special protected area, so that we don't have to repair our shot with shell more often. The other cross section is that one, which is a cross section in the mining area. Why did we choose this section? You have to imagine we have many tunnels which have a cross section which is not large enough to fulfill the safety standards. Because today, if I jump back to my one slide on the railway, you see that we have some safety pathway which is 1.20 meters wide and 2.20 meters high. And in many tunnels, older tunnels, which are, let's say, more than 100 years old, this space is not given. So what we have to do in future is for sure to develop a methodology to be able to enlarge this cross section in a proper way, so that you can also use the tunnel in parallel, but at the same time enlarging the system. The interesting point is, for such tunnels, 100 years old and older, we don't have any design drawings available. We don't have any static calculations available. What we have is a national archive in our main capital city, Vienna, where everything is, let's say, was reported when they built the tunnel. And we are sitting in this National Gallery or library to find out, okay, how was it built, and what were the, let's say, difficult situations by building these tunnels, to be informed for enlarging these profiles later on. And as I say, I mean, we are in a research center. Here we have time enough to develop technologies to do that, hopefully on a mechanical or mechanized way, so that we don't have to close all these old tunnels by enlarging them. You know, so the interesting technology is to develop something where we can use in a real tunnel, in a real railway tunnel, for example. We can use the tunnel, and in parallel we are working on the enlargement. Yeah, with all of this, we are involved in a project which is called Future Circular Collider, because one of our topics is reusing tunnel excavation material. And the Future Circular Collider is a project which has a length of about 100 kilometers, a research tunnel in Switzerland for TAIym. You might have heard it. It's between Switzerland and France, and they are in principle physicists who are looking for how did the Earth, let's say, develop, how was everything created, and they are looking for the smallest parts whichever somebody can think, and for this they need quite a large structure of tunnels. And this new gallery, which should be built from 2030 onwards, studies are now done. This is a sketch of this tunnel gallery. These are the almost 100 kilometers. There are some shafts to go down, and this is then this, let's say, accelerating tunnel which is under construction. And our job there is to find out a very good reuse of the material, which is mainly molasses. And therefore TAIym did a small film, and I would like to show the film in a few seconds.
Building greener cities. Laying the roads and tracks of tomorrow. Feeding soils to grow new forests and crops. How can you use molasses materials to make our future brighter and our economy more circular? The International Future Circular Collider project studies the construction of a new generation of particle colliders at CERN. Digging a tunnel for these colliders would create 9 million cubic meters of soil, mainly molasses. Can your technology put this soil to better use? Apply for the Mining the Future contest. Win up to €40,000 in support to bring your innovation to market and take part in a groundbreaking reuse experiment. Are you ready to mine the future? Participate now.
So what we did is a contest. We did a lot of lab tests on the material which we got from there, and then we're searching on our own on the best possibilities to reuse this in the industry or directly on the construction site, because we are running out of landfills. Yeah, so it is not state of the art today to bring excavation material to a landfill. No, we should really try to reuse this material, because it's a material like in the mine. That's why we call it mining the future. This was one topic. The other topic, what we are standing for, I would say, is we are trying to get better shotcrete qualities in future. We have to train miners on bringing up this shotcrete in a better way, because we are living majorly from the quality of the shotcrete lining. We are talking about life cycle, and if we are talking about life cycle in railway engineering, we are now talking about 150 years. So it is a must that this quality of the shotcrete raises up and is brought up in a proper way. So on the one hand side, we have to train the people who are bringing up the shotcrete. And on the other side, we also, what we are doing here is we are testing the shotcrete samples. We have to train people how to test the shotcrete, what tests have to be done, how to operate with this young and fresh shotcrete in the lab, and how to make the long-term tests. In Leoben, where I'm sitting at this Montan Universität, here we have a climatic cell, and in the climatic cell we have long-term devices for testing materials on the long run under given temperature conditions, given humidity conditions, and of course with a given load which we can bring up on these samples. Furthermore, we are not only on conventional tunneling, which we call NATM, New Austrian Tunneling Method, we are also working on questions of the mechanized tunnels, so TBM tunnels. And therefore, we have a test facility built up quite close to here where I'm sitting to really test these quite big blocks on their possibility to carry loads, not only in the vertical direction, but also in the horizontal, so that you have a bending moment then, of course, in. And the question is, can we put these, or can we build these materials using new materials, especially excavation material from the tunnels? And that's what we try to do, and we are trying to use fibers from steel, fibers from plastic, macro fibers, plastic macro fibers, but of course also the polypropylene fibers for the fire is a topic. And on this test facility, we can really go to the limits and look if which material, which reinforcement content, fibers or rebars, bringing which result on the carriage of such an element. And these elements are then equipped with glass fibers so that we can really see what is going on inside this element. And based on that, we have produced quite a lot of tubing elements, which can then be tested in our large-scale underground system to answer the question, is it possible to build the system single-lined, or would it, in case of a fire, collapse? This is a question which is quite new and has to be worked on. Another topic which we try to solve in the Zentrum am Berg is that we equipped some parts with so-called glass fibers in the shotcrete lining. So the question is, can we observe the life cycle, or let's say the stability of the tunnel on the long run without bringing some reflectors in the tunnel? Is it possible to do it also in other ways? And that's what we tried there. In this underground research center, we try to work together with the fire brigades. They are working on their questions, which are the new, let's say, materials or substances with which they can bring down the fire in a very short time. And we are working on the question, okay, what is the load which is coming to the lining, shotcrete or inner lining, and what is then the damage on our structure, and how can we bring better materials maybe to this lining, outer lining, inner lining, whatever, and what are the real temperatures depending on the megawatt of fire what we have. In this regard, we also, of course, are interested in what is going on if we would put an electric car into the tunnel. How would this go ahead? Is it possible to do fire distinguishing for electric cars, yes or no? And for that, we have to train, of course, the fire brigades. I mean, I don't know how you are structured, but we have, I would say, more than 90% of voluntary fire brigades people. So they have to have the opportunity to be trained under such conditions. As I mentioned before, we are also testing electric cars, and we made a quite huge research project together with these colleagues standing on this slide. And I would like to show you just a short video on the question, okay, how is an electric car behaving underground? And please have a look how the fire develops and how it starts. So it starts quite small, I would say, but after a while it goes to be a quite big fire, and then of course, depending on the charging of the batteries, it ends up sooner or later. Just a small impression of these tests. This is when it started. And this is after a while, you see left-hand side the time after about 14 minutes. So it really got So this is just a small impression. The project was called Brava, and it's published here and there already, so that you can also see the details on the outcomes of these tests. At the same time, we do also training and research with our students, especially what happens in case of an accident in the construction stage. This has to be trained. You must know as a construction site manager whom to inform and how then the chain is informed from the moment where it starts, and how everybody reacts and who has to do what. And this is a training which we also try to do with our students, because when they are ready with their master course, then they could be, or they could quite quick be responsible for the tunnel construction site. And we said it might be better to train them on such quite realistic scenarios. In that regard, we also have some European projects. What you see here is a picture of the Horizon 2020 project, which was called Iron Ore, which was European research project with the question, if we have a mass carambolage in an underground structure, having about 1,000 people in the tunnel, how do we get them at the quickest out, and who has to do what? So here we were working with the Croatian and Hungarian, but also German rescue teams to see how it works, how can we work together, how can we work together between fire brigades and rescue teams. And it was a very interesting exercise, and we have the same exercise also, or had the same exercise also this year. Not only the underground miners for traffic tunnels are trained. What you see here is a Polish group. They had 4 people to rescue. This was an exercise. Of course, we placed 4 people in very different areas in the small scale galleries, and their job was to rescue them within a certain given time. And they had to manage this situation. Smoke in, and 4 different, I have to say, 4 different scenarios were trained at this point. In this regard, I wanted to show you a small video of what is under development right now. Maybe you saw this already. Is a machinery which is not driving on wheels, but is walking. Because the situation in a tunnel is that in many cases, if you have an accident in there, you cannot really drive on wheels, because it's not possible, because there are cars which crashed and so on, so that you cannot bypass. And we said it's necessary to have some instrument which is able to walk through the tunnel, have a camera on this device mounted, which tells you the temperature, which tells you or sends some photos out of the underground, so that people standing outside of the underground structure get an imagination what is going on inside and where to go. And the short video just will show you that we placed a student in the underground structure, not knowing to anybody where he is. And we wanted to find the student by having a camera which was detecting different temperatures. Of course, the body of a human has about 36 to 37 degrees, which is a quite high difference to the temperature which is around in the tunnel. And the question was, are we able to detect the person? One we set in the tunnel, the other we set in a bus. Is it possible for the device to detect and then send the coordinates out to the office so that these rescue teams are then able to get straight forward to the person which has to be rescued? And this is a short film just showing the technology. You see, the apparatus was able to detect the student, and now it's going into the bus, and the question is, can we detect? And it was possible. And of course, with this device, then we are able to tell the rescue guys who are waiting at the portal location where to go, because we send them or we give them the coordinates where they should quickly go because a person is here and there. And this was the training which was done there. Development, I have to say, is not ready here and there, so we are fully working on these questions. Another complete other training, what we do is training miners, training real miners who want to be updated with newest machine technologies. Here we have the good luck that the construction companies were sitting together and created together with us a curriculum. It goes for a little bit more than or a little bit less than 4 months. And the miners are trained in bit of theory and majorly on practical works. And the miners are sent by the construction industry. We take normally 2 of each construction company, of these ones which are mentioned here, because they finance all these trainings and they organize all the machines and all the equipment and all the material which we need to make a progress in the tunnel, and under of course given conditions, under, I would say, safe conditions. Then we have a central point for safety where we could also train operators how to operate a tunnel. You see here the 2 tunnel tubes, the railway tunnels, the motorway tunnels. Everything is equipped with video systems so that we can look at every point on the underground structure, what is happening. And of course, if there is a fire training, somebody has to operate from this central point for safety and give the commands also from there. Another topic which we are working on right now is TAIym. You all might know the word BIM. BIM is Building Information Modeling. We call it TAIym, Tunnel Information Modeling. And what we are doing here is that we are trying to bring this underground structure Zentrum am Berg to a real digital twin in all let's say levels, from geology, surveying, statics, then design, of course, and up to the operation of the tunnels. Everything should be digitized so that we have a digital twin fully operating. Our wish, of course, would be to connect all this design, contracts, and also then the invoicing with one model. This is then the platform TAIym, how we call it. A first step was done by doing a digitization of all these underground research center. And here we work together with these companies standing on the left-hand side. And they did a scan of the structure. And with this scan, I think one who was not here can very quickly get an impression how it looks like, and then try to make a video, run a video again. So this was a 1 week's job. They came here with their scanner, and they scanned all the system so that it was possible in 1 or 2 weeks time to have a full 3D model, and a quite realistic one. I mean, it's not accurate on the millimeter, but it gives you, I think, a very good impression in 3D how the system is looking like, and this is a real good progress on the way of digitization of all these underground structures. I think this is a way for the future, because then we can work with the 3D models in our design stage already, walk through the tunnel as I do it like here. And I think this is a future. The 2D drawings, I think, slowly will run out in future and will be replaced by these quite realistic 3D scenarios. What else can be done or is done? Now we have this center where we can really play around with ventilation. I mentioned it at the beginning. So we can build up structures where we can mount all these, let's say, pressure cells, anemometers, so that we can really measure the pressure, the ventilation speed, gases in a real scale tunnel. If we would like to do that in the realistic tunnels, we would have to close them for several weeks. And at least in our region, you cannot get a tunnel for several weeks, neither from the railway organizations nor from the motorway organizations, because they are full of traffic. So we are very happy now to be able to study really ventilation questions. So to extend the numerical simulations by real measurements and calibrate these simulations now by having these real measurements available, we can place lorries in, we can place cars in, so that we get the differences out of different ventilation scenarios, and then make the simulations based on that much better in future. This would be the wish. One last thing what I wanted to tell you is research on energy storage. Here, I mean, it's not a new idea. Was done in US already in 1958. Was also done in Germany some years later. Where the question is, can we today produce wind or solar energy and produce compressed air out of it? By the production of compressed air, then we can store this compressed air in an underground facility. It produces heat. We store the heat down there, and in the evening, when the people are at home, we can then produce electricity and heat. During the day, most people are at work, so it is a pity that we are producing wind energy and solar energy, but nobody is at home. So the question was, can we create a daily storage underground, so that the wind and the solar energy are stored there, and when we need it in the evening, we can use it. I have to say we are in a small scale project working on that. We are not right now in this tunnel. This is a future vision if that works, but I just wanted to give you a small indication what we are thinking on. So you see, wind energy is produces electricity. Electricity produces this compressed air and also heat during the day, and during the night we are putting this heat and also the pressure from the cavern into this generator, and the generator then produces the electric energy. That is the vision which we have, and we are trying to solve this problem for the future. Yeah, and with this, I'm coming to the end with a Glück auf, as we say. So good luck for your time in tunneling. I end my presentation and I'm open for questions. I'm looking forward. Thanks for listening.
Thank you, Professor Geller, for a wonderful presentation. I just have a doubt that what arrangements you have done for the drainage, water drainage, like the full tunnel, because it's quite long, right?
You mean the diameter of the drainage pipes, what you saw on the sketches?
No, the drainage disposal systems, how we are disposing the drain, the water, drain waters and all.
Yeah, I mean, this is a quite normal standard here in Europe that you have a shotcrete shell, then you have your drainage pipes, then you follow with the sealing, and the water is now coming through the shotcrete shell because this is not a watertight one, goes into the drainage pipes, and then goes back directly to the rivers or to the sea because it's fresh, clean drinking water. So you just suck down the water from the mountain, you fill it into the pipes, and the pipes then bring it back to the riverside or wherever, whatever is possible to let it out. We have a completely separated system between the outer drainage of the mountain water, which is drinking water, and the system from inside, where of course there could also be petrol or diesel or whatever come into the pipes. But this is a complete separated system. The liquids from inside the tunnel, they are collected at the end at the portal location of the tunnels, and then they are pumped out or they are cleaned quite close to the portal location.
Thank you, Dr. Geller. Does anyone have any questions?
Yes, one thing I would like to ask. Before that, Dr. Geller, it was an excellent presentation, and I recall we visited that site about in 2017 when we visited Montan University.
Yep.
That was just beginning.
Yeah.
And you have done a great job in last 4 years. Fantastic facilities.
Thank you. We opened it in 2021. If you are there, Professor Botnis, on Wednesday, 23rd of November, we will have a dinner up there and having a site visit in the evening through all the system. I don't know if you're still there. Yep. If you're there.
I will not miss this opportunity, sir.
Okay, perfect. I'm looking forward.
Great. And one more thing, what is the cost involved? It's a huge cost for the whole project. It's a really big project, and the cost involved is really big. So how you managed? Did you get any research funding from government or from companies?
Yes, I have to say it wouldn't have been possible without that. It's a governmental project, so to say. So the government said, okay, we need such a facility in Austria to develop underground engineering further, and it was majorly paid, let's say, by our Ministry for Research and Education. Then it was paid by the Ministry of Infrastructure, which is today called the Climatic Ministry. Then it was paid by the province of Styria. This is the area where we are sitting. And then it was paid by the university itself. And I can tell you the sum because maybe you're thinking on how much is it. All in all, we had a cost of about 30 million euros. And this was brought up by these instances which I mentioned.
Oh. But fantastic thing you have done, sir. It's a really great.
Thank you.
Any other questions from the participants? Okay. So, sir, Professor Geller, I wanted to ask, are you planning to do any research on composite shell lining on these tunnels or something?
Yes, yes, this is for sure a topic. And as I mentioned, we are working on new materials. The question is, can we make the shotcrete better? Can we use, instead of the rebars, instead of the wire mesh, maybe fibers only? This is not allowed for the moment, but hopefully in future. And of course, we would like to make the shells thinner to get more sustainability, because most of CO2, and this is a topic at least here in Europe, is brought in by the cement. And the question is, can we maybe reduce a little bit the cement content, replace it by something else? So there are, I tell you, many questions along. We are, let's say, for the next 100 years, I would say we have a lot of questions to be solved.
Yeah, thank you, Professor Galler. So I think I'm sure your presentation was quite informative, and thank you for your detailed information on your project. And I'm sure your practices at ZAB will be very helpful for everyone, and our student members have got a clear idea on the topic. And I would like to inform all the participants that we have the past webinars on our YouTube channel. Kindly visit it. And once again, thank you, Professor Geller, for sharing your experience. And thank you all for joining. Have a great weekend. Stay safe and happy tunneling.